Hello, my name is Natasha Najwa Alia. My matrix number is 0186. Today I will present introduction, discussion and conclusion. First, introduction. What is DC boost? Due to increased use of battery-operated portable devices like mobile phone and laptop, switch mode DC to DC power source are now necessary power source. For the purpose of controlling the traction motor, DC converters are frequently employed in electric cars, trolley, marine hoists, forklift truck, and mine hauler. They deliver excellent acceleration control, great efficiency, and quick dynamic response. They can be applied to DC motor to provide regenerative braking, which recycle energy back into the supply. With frequent step, this characteristic help transportation systems save energy. The boost converter is used to step up an input voltage to some higher level required by a load. This unique capability is achieved by storing energy in an inductor and releasing it to the load at a higher voltage. This brief note highlights some of the more common pitfalls when using boost regulator.
Assalamualaikum, my name is Muhammad Azri bin Johari. My metric number is B0821100047. And here I'm going to talk about state of art. The first one is block system. Block diagram are a part of transfer function that depict the connection between input and output. Figure below is a such system. It is present as a block with an input, output and transfer function. There are three other basic forms of block diagram arrangement, namely a cascade form, parallel form, and feedback form. And each one of it can be simplified into a simple representation and produce its own transfer function. Next is type of controller use. The objective of a control system can be achieved by employing two possible control strategies. These control strategies are open loop control system, which is feed-forward control system, and closed loop control system, which is feedback control system. Figure 2.1 and figure 2.2 shows open loop control system and closed loop control system respectively. Next is transfer function of the plant use. Transfer function is defined as a ratio output to the input with all its initial condition is considered zero. Transfer function parameter as in table below. The first one is CS input signal, RS output signal, and parameter ZM. Zeros is the point that make the transfer function is zero if the value of Z equals to zero and P has a value. Zero equation can be obtained from the numerator equation. And the last one is parameter Pn. Poles are the point that make the transfer function has a value of infinity if Z equals to P equals to 0. Poles equation can be obtained from dominator equation. And here is the formula CS over S.
Assalamualaikum and hi, my name is Jason Wong bin Muhammad Fitri Wong. My matric number is B0821102297. I will present about the optimization method used. The DC to DC converter is a combination of reactive component and power device and widely used to desired current and voltage level efficiently. This category of converter need an accurate controller to control its static and dynamic performance. Proportional integrated derivative controller parameters are commonly functional to DC converter due to its straightforwardness. Design of controller is identifying as an optimization method to achieve desired dynamic response with the help of several algorithms. The algorithm used for optimization can find many prime results. In this paper, the DC to DC boost converter is investigated with different optimization techniques. Example GA, PSO, and BFO algorithm. Numerical metric laboratory 9.1 R2016B. Simulation results are provided, and various parameters of the controller, example time taken for the settle and rise the waveform. The peak is investigated from the step response curve. The response of the controller also compared in detail, and it can be concluded that BFA techniques are giving a better response when compared to another method. Next, for the advantages and disadvantages. Advantages can extend potential from partly reduced cell potential, available as whole hybrid circuit element, construct to make best usage of the energy yield for photovoltaic system. DC to DC converter has more energy transformer on condition of the barrier. Output of isolated converter is organized as positive or negative. Next, for disadvantages, switching converter are prone to noise, expensive, unsteady voltage and current supply. It is also known to be disadvantage of flyback type. More EMI due to the gap, more ripple current, more input-output capacitance, higher losses.
My name is Muhammad Laizat bin Muhammad Tazli, metric number B0821100067. I'm going to present for methodology. For mathematical model of DC boost converter 12 volt to 18 volt, the boost converter function is to maintain a regulated output voltage higher than its input voltage. Figure below shows the equivalent circuit of boost converter that has the following components: inductor, capacitor, resistor, MOSFET and diode. Shows the formula to decide the value of inductor, capacitor and resistor. This is the first step to calculate all the values, which is duty cycle. The minimum input voltage is used to lead to the maximum switch current. The formula is D equal to 1 minus V in minimum times N over V out. For inductor selection, the higher the inductor value, the higher is the maximum output current because of the reduced ripple current. The estimate for inductor ripple current is 20% to 40% of the output current. So the formula is IL equal to 0.2 to 0.4 times I out max times V out over V in. For the inductor selection, we'll determine using the formula L equal to V in times V out minus V in over IL times Fs times V out. For capacitor selection, for the capacitor selection, we need to determine the capacitor ripple voltage using the formula. So the formula is C out min equal to I out max times D over Fx times V out. For the block diagram, there are two modes that will be discussed in the paper. The first mode is when the Q is on and the second mode is when Q is off, as figure below. So the first figure is DC input voltage to DC converter mode 1. So the output is DC output voltage. For figure 2, DC input voltage to DC converter mode 2, and the output is DC output voltage. Each mode can be represented in the state space as following. So here is the equation for mode 1 and equation for mode 2. Where X is the state vector consists of inductor current and capacitor voltage. A1 and A2 are system in matrix. B1 and B2 are input in matrix. C1 and C2 are output matrix. E1 and E2 are feed forward matrix. For differential equation, The following differential equation were obtained by applying Kirchhoff's law. Equation is obtained by applying the voltage law in loop 1, and equation 2 is obtained applying the current law in node 1. So here is the circuit diagram. The following differential equation were obtained by applying Kirchhoff's law in figure 1. Equation 1 is obtained by applying the voltage law in loop 1, and equation 2 is obtained applying the current law in node 1. So equation 1 indicate the IL is increase its value, so the inductor is storing the energy. Equation 2 indicates VC in decreasing its value, so the capacitor is delivering energy. Equation 3 is obtained by applying the voltage law in loop 2, while equation 4 is obtained applying current law in node 1 as figure 1 shows. Equation 3 indicates that IL is decreasing its value, so the inductor is delivering energy. Equation 4 indicates that VC is decreasing its value, so the capacitor is storing energy. The switching function U is defined to conveniently write equation 1 to 4. When U equal 1, switch is closed, whereas when U equal 0, switch is open. Equation 1 and 3 are written as follow. Power and interchange of energy analysis. Table 1 and 2 provide an analysis of power and energy exchange. Table 1 correspond to the analysis when Q is closed, while Table 2 when Q is open. Positive value in voltage and current column indicate the element L, C, D or Q has the same voltage polarity of current direction that the polarities of current directions of the reference. Positive value in the power column indicate that the element is storing L and C or demand R, D and Q energy. Negative value in voltage and current columns indicate that the element L, C, D or Q has contrary voltage polarity of or current direction that the polarities of the current directions of the reference. Negative value in the power column indicate that the element is delivering L and C energy. Zero values in current and power columns indicate that D or Q is inverse polarized. No current and power are dissipated in the semiconductor. So this is the table 1 and 2 for the analysis.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Azim bin Amir Hussein, metric number B0821101169. Today I'm going to present on the result that we gained from this assignment mini project. So this is the circuit construct in Simulink. The component base on resistor 3.24 ohm. The inductor is 63.39 micro. The capacitor 406.69 micro. Voltage supply is 12 volt, the frequency is 25 kHz, and the duty cycle is 33%. The output voltage shows that 18 volt based on the circuit design that's shown below. So this is the simulation that we run on the Simulink, and this is the result that we gain from the simulation. So the IL that we gain is 8.33 ampere, and then the IO is 5.55 ampere, and then the inductance is 63.39 microhenry, and then the capacitor is 406.69 microfarad, and the load at rated power is 3.24 ohm. So this is the waveform that we gain from the simulation for Simulink. So the first one is the stability graph, and then the second one is the output voltage. And then this is the waveform for the inductor voltage, inductor current, and pulse. This is the state space mode 1 that we use. So the first loop is L, multiplied by DIL over dt equals to V in, and then DIL over dt equals to V in over L. And then the second loop is C dVC over dt equals to negative VC over R, and then dVC over dt equals to negative VC over RC. This is the formula to create the matrix for state space mode 1. And then this is the state space mode 2, which is loop 1, L multiply DIL over dt equals to V in minus VC, and then DIL over dt equals to V in over L minus VC over L. For second loop, C multiply dVC over dt equals to IL minus VC over R, and then dVC over dt equals to IL over RC minus VC over RC. So the left one is to create matrix for state space mode 2, and then we convert to average state space for mode 1 and mode 2.
Next discussion. The stimulation and outcome are described based on each input voltage separately as part of the discussion and to illustrate the associated output parameter and performance analysis. The performance study and parameter take into account boost converter. Finding the right part for the project was first very challenging, but we succeeded since we found something that could be put to use. We use MOSFET, diode, inductor, capacitor, and resistor for the component. The system parameters such as the circuit stability, output voltage, inductor current, and pulse from the aforementioned graph are included in the output representation. A MOSFET receives an excessive current for a brief duration while it is in the on state. Lastly, for the conclusion, first, we understand the fundamental of DC to DC boost converter. Second, DC to DC boost converter is also known as a boost converter that steps up voltage from its input, which is supply, and output, which is load. Next, the boost converter has a high frequency power. And lastly, we know how to use MATLAB and Simulink because our final testing, we construct the suggest control structure use those software. Thank you.